This diagram shows the normal to the function arctan of x on 7 at the point where x equals 7. Determine the equation of this normal and evaluate how reasonable my solution is with reference to the diagram. Well, if I'm going to work out the normal, I need to first work out the gradient of the tangent to work out the gradient of the normal. And the gradient of the tangent comes by differentiating. So, y equals tan to the minus 1 of x on 7. Pen doesn't like me. So y dashed then, what's the derivative of arctan of x on a? It's a squared, it's a over a squared plus x squared. So here it's 7 over 7 squared plus x squared. Okay, I need it at a particular point, at this point here, where x is 7. So, at x equals 7, y dashed is 7 over 7 squared plus 7 squared. Well, that's 7 over 2 times 7 squared, which I can simplify as 1 over 14. That's why I actually left it as 7 squared here. On this line I went, actually, rather than writing a number, I'm just going to be cancelling by dividing by 7 anyway, so like that. Well, if that's the gradient of the tangent, then the normal, the gradient of the normal is negative 1 over the gradient of the tangent. Do you remember that relationship? Sorry, I went off the bottom there. Do you remember this relationship? The gradient of the normal and the gradient of the tangent multiplied to negative 1. So in this case, the gradient of the normal is negative 14. Okay, let's work out the equation of that line here. I have a point on the line and I have the gradient. Actually, I haven't quite worked out the point yet. I've got the x-coordinate, but what's the y-coordinate? So still, at x equals 7, the y-coordinate is inverse tan of 7 on 7. You can see why they chose 7 as my x-coordinate, because it's making this very nice. What's the inverse tan of 1? Well, the inverse tan of 1 is 45 degrees, pi on 4. So this point here is 7 pi on 4. So I have a point, and I really have its full coordinates now, and I have a gradient of negative 14 down here. So now I can work out the equation of the line. Y minus y1 equals m x minus x1. Put in what I know. Y minus pi on 4 equals negative 14 x minus 7. Y minus pi on 4 is negative 14x plus 7 times 14. Well, that's 7 times 7 times 2. Was a number, one of the numbers over here I was trying to avoid calculating. 7 times 7 times 2 is 2 lots of 49, which is 98. So y then is negative 14x. This becomes plus 98 plus pi on 4. And that's perfectly good enough as my equation of my line. The last thing the question told me to do was evaluate the reasonableness. Does this look reasonable according to the diagram? Yes, it does. The gradient is steeply negative, looks steeply negative, and the y-intercept is very high up, and it looks like it would be a long way up. So yes, that is reasonable. And I should probably write that. Reasonable as line in diagram has steep negative gradient and large positive y-intercept.